So for this discussion, I decided to do questions 3.9b and 3.10 using counterpositive and the direct method. So for 3.9, I'm going to be using the counterpositive, and for 3.10, I'll be using the direct method. So 3.9 says, prove that n is an integer and 5n plus 4 is even, then n is even using contraposition. So if n is odd, then 5n plus 4 is odd. And how we got to this point is, so when you use contraposition, you're switching it from even to odd. So if it were to say that we're looking for 5n plus 4 is odd, then n is odd, we would switch it to we're looking for if n is even, then 5n plus 4 is even. But that is how we got to this conclusion for now. And then from there, we're going to assume that n is odd and 5n plus 4 is odd. So those are our assumptions. And from here, we will, so because it's odd, that means that we're using the n equals 2k plus 1, where k is an integer. Oops, where k is an integer. And from here, we'll end up doing 5n plus 4 equals, and then that's where we enter the what we have for n. So we're gonna put 5, 2k plus 1, plus 4. And then from here, we're basically just gonna keep, we're gonna expand the expression to get the lowest form of the expression possible. So here it's gonna be 10k plus 5 plus 4. And then this will be equal to 10k plus 9. And from here, instead of trying to figure out if we can go any lower, which we can't for now, we would have to factor out a 2 in order to go lower. So it'd be factor out the 2, and it'd be 2 5k in parentheses plus 4 equals, oh, sorry, plus 1. And then, so with our 5k plus 4, it's in parentheses, but because it's an integer, we're gonna make it a C. So this will be 2c plus 1. And then right here, you can see, because we have that plus 1, because we have the plus 1, that would make this odd. So it basically tells us that our statement's true. If n is odd, then 5n plus 4 is odd. And since that makes this statement true, that would make this statement over here true. Because if 5n plus 4 is odd and n is odd, then 5n plus 4 is even and n is even. And then now for our next question, it'll be 3.10. Prove a is even if and only if a squared is even. So this one we're going to use the direct method. So we're assuming a is even. That's our first assumption given from the prompt. And then from here, we're going to use what we got in the book, which would be a equals 2k, where k is an integer. And then from there, we would just input it like we did with their contrapositive, which would be a squared equals 2k. And then from here, we're basically just gonna keep expanding the expression. So it's gonna be 2k squared, which is, if we separate them, it'll be 2k in parentheses, and again 2k in parentheses. And then from here, it would be, we would end up getting 4k squared. And that would be 2k, squared. So it's basically just the same thing we did as a contrapositive, but this is just a direct method. We're just doing basically if p then q. That's all it is. So it'll be a squared equals 2k squared equals 2k times 2k equals 4k squared equals, we factored out a 2, and then 2k squared. So from here, we can already see that our answer here is even. So because this is even, a squared is even. Therefore, proving that a is even if and only if a squared is even. And that is how you use the contrapositive and direct method approach.